So let's start. Hello and welcome to my talk from DAW to Game Engine Unfiltered Creativity. In this session, we'll be sharing you about my journey from creating sound in a DAW to building game audio systems. And by the end of this talk, I hope to share with you how audio workflows look in a game. To make it easier, let me break down into the steps. First step, basic sound integration and playback. Second is adding dynamic and immersive audio behavior. And third is audio optimization. Before diving into the steps, a quick introduction. I am Nikhil Dahake. I have around 8 years of experience in the field of audio, and I am a FTI sound graduate. I have worked as a sound editor for various films and web series where I used to do track laying, sound designing, or any other audio post-production works. And for the last 5 years, I am developing game and designing sounds for them. I am currently working at Super Gaming as a game developer. About Super Gaming, a 100-people gaming studio based in Pune, India. And for the last 10 years, we are creating real-time multiplayer games for mobile. So our most ambitious project is DAWx, a 60-player battle royale shooter game for Android and iOS. And yeah, it's available in India, so you can download it from Play Store. So inside DAWx, we are using Unity as a game engine and its built-in audio system. And on the top of it, we have created our own tools and our own audio systems, which we call Audiograph and Audio Copilot. With a basic introduction, let's start with discussing audio in DAW versus audio in game engine. So when I was working in a film, my job is to find the sound elements inside the frame, design them, and make that scene very aesthetically impactful. And since Shriji sir is there, he might have a good idea of sound design. And films, audio follows a fixed timeline, and it is a non-interactive media, whereas games is an interactive media where audio is triggered by gameplay events. We have to design sounds for each feature, integrate them into the engine, and have to set up the playbacks. With this, let's start with step 1, basic sound integration and playback. So design your audio clip in a DAW. You can use any DAW. So I am using Avid Pro Tools. Integrate them into the engine. Set up the audio parameters like volume, mixers, channels. And this is a simple way to play audio in a game engine. I am showing you Unity's play one shot function where you have to pass the audio and audio will be triggered as per your requirement. Now let's take a simple example, which is player jump audio system, to understand how events and playback works together. So it has 2 types of events inside this system. First is jump start, and second is jump end. So after integrating sounds for this, it sounds like this inside the engine. Okay, you might be thinking why I'm showing you such a basic example, but as a sound designer, I might create a single clip for whole animation. But in future, if there is some decisions if we have to change the animation speed or any height speed, so there may be chances of getting that audio out of sync. So as an audio designer, I have to take a call that we have to create separate audios for separate events. With this, let's recap step 1. Become familiar with game engine, mostly on audio, playback, and integration part, and understand the game system and events before diving into sound design. We have completed step 1, basic sound integration and playback. Now let's start with step 2, adding dynamic and immersive audio behavior, which is one of my favorite, and I think you will also like this. So what is dynamic audio in games? Sound that changes in real time based on game states. And what is immersive audio in games? Sound that makes player feel like they are inside the game. And any guesses from audience? Why is dynamic and immersive audio important in a game? Any wild guesses? Coffee अगर नहीं पिए क्या आप लोग? Yeah? Okay, so for me, yeah, it's my point actually. So for me, it's a gameplay feel. Like if player running on different surfaces like metal, sand, water. So different surfaces has different footstep sound. And the other one was your point, gameplay feedback. Ki, if a player health is low, so as a sound designer, I might trigger a heartbeat sound or any warning sound to get a. So this sound will instantly notify the player that your health is low and you have to recharge yourself. Let's take a real-time example, which is enemy footsteps. So in battle royale shooting game, enemy footsteps plays an important role, and with the help of that sound, player easily notice or judge the position of that enemy, and on the basis of that, he decide whether to take fight or defend. So we already have a 3D audio working inside the game, like the left-right panning and the distance-based volume attenuation. Like if enemy is far away from me, that distance will be less, and if it's nearby me, it will be louder. But the problem here was elevation. So we don't have any different audio treatment if enemy is above me, and same for below. And again, we are creating a game for low-end devices. So we can't use any heavy processing plugin like HRTF or any heavy plugins to adjust this thing. So we are using equalizer, which is our favorite plugin. So if enemy is above player, we are boosting low frequencies to get the thumpiness feel of that sound. And if it's below me, we are adding a telephonic effect to it. Let's see how it sounds in the engine. So these kinds of techniques help in improving the gameplay. Let's take another example, which is gun firing sound. So we are having two types of weapons inside Indus BRX. First one is single fire. So single fire is just one click, one sound. We are pressing the trigger and sound will be triggered. Let's see the example of sniper for this. How was it sounding, by the way? Acha. Energy is very low, by the way, promise. Fine. The other one is automatic fire. So for automatic fire, fire rate plays an important role, and fire rate gives a behavior to the weapons. So let me quickly show you the low fire rate and high fire rate. And the high fire rate.
Reloading.
Did you notice the difference, like why fire rate is important? And while designing such kind of sounds, fire rate should be considered. So in order to enhance our gunfire sound, so we wanted to add a weightage to that sound. So at the end of each fire cycle, we are triggering reverb tail and shell drop SFX. Let's see how it sounds in the game.
Reloading.
It gives the overall feel. Let's take interior and exterior audio behavior, which is an environmental based example. So we wanted a different audio treatment when player is firing inside any room or any building. So which is the plugin, like in this case, which plugin should I use? It's one of the favorite plugin. Quickly. Reverb. Yeah, reverb is the correct answer. But the tricky part here is detecting the interior. So let me show you how we did this. So we are simply checking if there is any roof above the player. And if there is any roof above the player, we are enabling the reverb to that sounds. Let's see how it sounds. Let's take other example, which is Rails audio system. So Rails are very cool feature in a game where a player uses it to quickly change from one position to another. So let's discuss sounds and events for this. Okay, nice. See. So first one is play one shot. Let's discuss the events for this. We have start jump, speed boost, braking, and rotation. Like we have a different sounds for these categories. And in the looping section, we are having, so by the way, looping is that audio which we are like playing it in multiple times for a continuous activity. So this is a high speed, like you can see it's a continuous activity. So we are using the same audio clip multiple times. So this is high speed and this is low speed. And again, it's a very complex system with lot of events inside the game. Let me show you the audio video for this, how it sounds. Let's take one last example, which is player dive audio. So it's a sequence in our game when player jumps from a flight to battleground to start fight. Let's study the event on SFX for this. So we have three types of events inside this. The first one is dive start, where we are triggering the jet loop SFX and wind loop SFX. And during dive, we are controlling the pitch and volume of the jet. Like if player speed is high, we are boosting pitch and volume of that, and vice versa for the wind. And at last, we have the landing impact, where we are stopping all audio and triggering the impact SFX. Let's see the audio video for this. So let's recap step 2. Immersive and dynamic audio is important for gameplay feel and feedback. And audio behavior must change with respect to environment, like which we have seen in the interior and exterior audio behavior of the weapons. And the last one is understanding gameplay parameters helps in modulating the sounds, which we have seen in the last example, where we are using the speed to control pitch and volume. With this, we have completed step 2, adding dynamic and immersive audio behavior. So in my studio, I was very happy, like all audios are there inside the completed the audios, and I was ahead of my deadline, and I was very happy. All audio levels are sorted inside the game. But one of my bad friend come to me and tells me there is an issue with the game, which is a performance issue. And since we are creating the games for low-end devices, let me break this down for you. What were the issues? So game's build size is huge, so players are not downloading our build. Game is crashing consistently, and game is lagging. Like there is a lot of FPS drop, stutter, and the heating issues inside the game. With this, I welcome you to the world of audio optimization. It's very hard actually. So first one, let's start with reducing build size. So in our first build, around 200 MB was the total size of audio inside the total build. And we have reduced it to 45 MB. Let me show you how we did this. Simple. Convert stereo to mono. Like you can take any UI sounds or any tertiary sound, which is not important for gameplay. Just convert it to mono. For similar audios, you can lower the sample rate and use correct audio format like .oggs, .flag. They are very lighter in size. And trim unnecessary audio length, like avoid long fade outs in a game. Don't keep any unnecessary information in the audio clip, and keep that clip tight and cut to cut. And this is a very helpful tool, and my favorite tool by the way. It's a memory profiler where you can individually check the size of audio in a game, or maybe size of images, or maybe size of scripts. I'm showing you Unity's memory profiler. It will show you something like this, total size of audio. With this, we have reduced build size. I think अब appraisal मिलेगा मेरे को. ठीक है. Why do games crash? So let's study why do games crash. Again, this is a low-end device of 4 GB RAM. Some amount is consumed by system reserved. When we start games, some amount is consumed by game models like 3D models of the game. And you can see that's filling in the below side. Some amount is consumed by images of the game. And some amount is consumed by animation and VFX. And you can see it may be crossed the limit of that RAM. And when audio loads, limit is exceeded and your game will crash. Happy birthday. Okay. So let's solve this with the help of reducing RAM usage. So in terms of audio, there is something called load and unload audio technique. This is our main menu, and again you can see it's a 4 GB RAM. Some amount is consumed by system. Some amount is consumed by the menu, the graphics, the VFX, the character, all over that thing. And you can see below 20 MB is consumed by the music, which is background music for that menu. And when player enters into the scene or any game mode or any gameplay, we don't want that main menu music to be taken forward. Instead, we can simply unload that audio. There are a lot of techniques to do this. You can refer the documentation also for this. So yeah, we have to unload the audio. And with this, we have optimized the RAM. Now let's study why do games lag. Multiple game processes like VFXs, SFXs, and a lot of complex calculations running simultaneously, it will lead to high CPU spike. And due to this, your game start lagging, device heating issues are there inside the game, and stuttering issue. To solve this, we have to reduce CPU usage. You can minimize the DSP effects like reverb, compressor, EQ, because it's very expensive, so don't misuse this. You can use something called distance-based audio removing. Let me explain you what is this. If you can see far away from the player, there is some action going on. But that sounds are not audible to me, like audible to player. But in the background, they are playing in the background. You can see there are a lot of audio sources playing, which is firing, maybe bullet surface impacts, maybe footsteps. And it's unnecessary taking up the CPU. And by the way, this is an audio profiler. Tool. So you can use something called distance-based audio removing. So you have to form a radius, and after that radius, that audio will be bypassed. With this, I think मेरा appraisal हो गया उसके बाद. फिर we have optimized the audio asset through reduced build size, use load and unload audio techniques to optimize RAM, and keep your audio playback efficient to optimize CPU. With this, we have reduced build size, reduced RAM usage, and reduced CPU usage. We have completed all the steps. And let's takeaways. So if you are creating any games for future, keep these points in mind for audio kind of thing. Game audio is not just sound, it's a core part of player experience. Sound around knowledge combined with engine expertise creates immersive soundscape, and optimized audio contributes to smoother and more efficient gameplay. And most importantly, remember to have fun while working. With this, thank you for listening.